I'm asking you to determine which statements are correct about how the data is divided into groups, folds, for cross-validation. We'll analyze the results of using Sklearn's KFold function. We have 12 data points to work with, which will be split into folds. This is our raw material. I'm using KFold, a function that splits data into K groups, folds, for cross-validation. The n_ splits parameter is set to 3, meaning I want 3 folds. Shuffle equals true means I randomly reorder the data before splitting into folds. The final outcome. My data will be divided into 3 distinct groups called folds. Each fold will be used once as a test set, while the remaining folds are used for training. This represents the third and final group of data samples in the 3-fold split. I'm using KFold cross-validation, so this group will serve as the test set while the samples in fold 1 and fold 2 are combined to form the training set for this iteration. Remember, I'm shuffling the data first, so these samples are not simply the last 4 items. This is the second group of data samples. In this round of cross-validation, it acts as the test set. The data in fold 1 and fold 3 becomes the training set. Again, the shuffle ensures these aren't just consecutive data points. Here, we have the first group of samples. In the first iteration of 3-fold cross-validation, these will be the test set, with the data in fold 2 and fold 3 acting as the training set. Because of set, the samples here aren't just the first 4 of the original dataset. I'm imagining 12 data points, maybe representing things like house prices or patient medical records. These are the things we'll split up for cross-validation. Think of it like having 12 cookies that need to be divided fairly. I'm using Sklearn's KFold tool, a popular way to do cross-validation. n_ splits equals 3 tells it to divide my data into 3 groups, or folds. Shuffle equals true means I'll randomly mix up my data first. It's like shuffling the deck of cards before dealing. So the folds aren't just the first 4 cookies, then the next 4, and so on. This helps avoid bias. After the shuffle and split, I have 3 separate groups of data. Each group will be used for testing, while the others are used for training the model. This is repeated 3 times, using each group as the test set once, for a robust evaluation. It's like making 3 batches of cookies. Each batch gets a turn to be tested and evaluated separately. This is the quiz question. We'll figure out which statements are true or false about the way the data has been split. Because I have 12 samples and 3 folds, ideally each fold would have 4 samples. 12 divided by 3 equals 4. However, that is only exactly true if it's not a stratified split. If the data has labels, KFold might adjust things to keep the proportions of each label similar in all the folds. Think of it as carefully dividing cookies with different types, chocolate chip, oatmeal, etc., to ensure you have a similar distribution in every batch. This statement is false. Mutually exclusive means they share no cookies in common, but in KFold, the training sets overlap. A cookie in one training set might be used in another training set. This is true. Each test set gets its own unique set of cookies, mutually exclusive, and all the cookies are used in a test set at some point, collectively cover all samples. If we don't shuffle the data, shuffle equals false then the folds contain cookies in sequence. It's like dealing the cookies out without mixing them first. This sets up the scenario. We're using a technique called KFold cross-validation to evaluate a model fairly. We've got 12 samples, data points. We're creating 3 folds, and we're shuffling them randomly before splitting. I'm using Sklearn's KFold to split 12 data samples into 3 groups for cross-validation. I'm randomly shuffling the data first, then making 3 folds. KFold stands for K-folds, where K is the number of folds you want. I have 12 data points that I'm working with. I will divide my 12 data samples into 3 distinct groups, called folds. Each fold will be used once as a testing set, while the rest are used for training. In fold 1, I'll use some of the samples for training my model and hold the rest out for testing. I am using KFold, which ensures each sample is used exactly once for testing and multiple times for training. Similar to fold 1, fold 2 will also have a training set and a test set. The crucial point is that the test set here will be different from fold 1's test set. The same idea applies here. a training set and a unique test set distinct from folds 1 and 2. This is all done with a specific algorithm for the sake of better model evaluation and less bias. This means that each data sample will appear in only *1 test set across the 3 folds, and together all the test sets will include all 12 samples. That's pretty neat. I'm using Sklearn's KFold, a technique for splitting data into multiple folds for cross-validation. I have 12 samples of data, and I'm dividing them into 3 folds. KFold stands for K-folds. The K represents the number of folds. I'm asking you to identify which statements about how the data is split are true. This is all about understanding how KFold works. Ideally, yes, because 12 samples divided by 3 folds equals 4 samples per fold. But I use stratified KFold, which prioritizes maintaining class proportions in each fold. So, this might not be perfectly even. Nope. Mutually exclusive means no overlap. In KFold, some data points used for training in one fold will also be used for training in other folds. Think of it like sharing toys. Some toys are used in multiple games. Bingo! Each data point is in only *1 test set, and together, all the test sets include all the data. Absolutely. If I don't shuffle the data, the folds will just be sequential chunks of data, like taking slices of a cake without mixing it up first. I'm working with a dataset containing 12 individual data points. I've set the number of folds to 3, splitting my data into 3 groups. I've set this parameter to randomly shuffle my data before making the folds. This ensures a more random and balanced split. Without shuffling, my folds would be consecutive parts of the data, which might not be very representative. One of the 3 folds created by the KFold process. The data in this fold is used once as a testing set and twice as a training set. Similar to fold 1. This is a second fold. The data here is used once as a testing set and twice as a training set. The final fold. Its data is also used once for testing and twice for training. I see you're working with KFold, a technique in Sklearn that's used for cross-validation. You have 12 samples of data and you've decided to split it into 3 folds, meaning 3 different sets of data will be used for training and testing. The "shuffle" equals true part means the data will be randomly mixed up before splitting. The stratified part is important if the data has different categories. It ensures a similar proportion of each category is kept across all the folds. Let's check the possible answers. Ideally, with 12 samples and 3 folds, each fold would have 4 samples. 12 divided by 3 equals 4. However, because we're using stratified KFold, which tries to maintain the same proportion of different data categories in each fold, it might not be exactly 4 in each. It will be close to 4, but not necessarily exactly 4 samples. This statement says that the samples used for training in one fold are never used for training in another fold. This is false. Think about it like this. If a sample is not * in the test set for a fold, it must be in the training set for that fold. Since the test sets are different for each fold, the training sets will overlap. This is true. The test sets will have no samples in common, and every sample in the original dataset will appear in exactly one test set. That's how KFold works. This is also true. If you don't shuffle your data before splitting, "shuffle" equals false. The folds will simply be consecutive chunks of your data. So, the first fold would get the first few samples, the second fold the next few, and so on. I have 12 data points, like 12 students' test scores. Think of them as individual data points to be split into groups. I'm going to randomly mix up these 12 scores before dividing them into groups. This ensures that the groups are not just consecutive chunks of data. It's like shuffling a deck of cards before dealing. I'll divide the shuffled 12 data points into 3 separate groups, called folds. Each fold will be used for a part of the analysis. Ideally, each fold would have 4 samples, 12 samples. 3 folds equals 4 samples, fold. However, because I'm using stratified KFold cross-validation which maintains the class proportion in each fold, it's possible to have a slight variation in the number of samples per fold to maintain balance. This is false. The training sets will overlap because some data points will be in the training sets of multiple folds. Think of it like this. Some students' scores will be used to train the model in several different rounds. This is true. Each sample will only be in one test set, and every sample will be in a test set at some point. Each data point gets its turn in the spotlight. This is also true. If I don't shuffle, the first fold would get the first few samples, the second fold the next few, and so on. It's like dividing students' scores into groups by their seating arrangement.